All right, we're going to be starting a unit on trigonometry. And before we really get into that unit, what I want to do is go back and review some trigonometry that you've probably already learned before. So trigonometry, we'll get more into the definitions later, but it's just really anything related to right triangles. So technically, when you do Pythagorean theorem, that's trigonometry. But when we talk about trigonometry, what we're usually talking about is these trigonometry functions or identities, which are sine, cosine, and tangent. And then there's a few more that we'll look at in a second. But so that's what we're talking about, sine, cosine, and tangent. And just a reminder on what those are. Those are ratios or fractions that tell you when you have a certain angle in a right triangle, what will the ratio of different sides of that triangle have to end up being? And the way we remember which one is which ratio is which, is with this acronym, SOHCAHTOA. So just a quick refresher on what SOHCAHTOA is, if you learned it that way. And get a color here that works. SOH means sine of an angle. And usually when we're talking about angles, we use the variable theta, the Greek letter theta. You don't have to. You could say x or anything else, but that's just kind of what we commonly use for angles. So sine of our angle theta is equal to the ratio of the opposite side over the hypotenuse of the right triangle. And if you look at your right triangle, your hypotenuse, of course, is always the longest side. It's the side that's across from the right angle. Your opposite side is the side that is opposite the angle you're working with. So here, my marked angle is angle T. So the side that's opposite angle T, the side that's not touching it at all, is this 7 over here, side CA. So this is the opposite side. All right, the second trigonometry identity is the cosine, and the cosine of an angle is the ratio of the adjacent side to the hypotenuse. Now the adjacent side, adjacent means next to or touching. And if you look at angle T, there's two adjacent sides, but one of them is already labeled. It's the hypotenuse. So the adjacent side is the adjacent side that is not the hypotenuse. So it's the 24 here. And then finally, we have tangent. And your tangent of an angle is the ratio of the opposite side to the adjacent side. And why this is important or useful here is because for any angle, no matter how big your triangle is, if you have an angle that is a certain measurement, the sine, the cosine, and the tangent of that angle will always be the same. And that can be helpful because sometimes you don't know the angle, but you do know the measurements of the sides. It's a lot easier to measure a side of a triangle, to measure a length, than it is to measure an angle. So if you know the lengths, the distances, then you can use those to figure out what angle would give you that ratio. So you can do it a couple different ways. And as we get into this unit, what you'll find is there's a whole other realm of trigonometry based on these simple ratios that can be applied in a lot more places. But anyways, getting back to this, we have this triangle. It's got a 7, a 24, and a 25. That's if you remember, that's called a Pythagorean triple, 3 whole numbers that could be the sides of a right triangle. And if we want to find the sine, the cosine, and the tangent, we would just make ratios here. So our sine is opposite over hypotenuse. That would be 7 over 25. And if you wanted to, you could make that into a decimal. 7 over 25 becomes 0.28. Cosine of that angle is the adjacent over the hypotenuse, so that's 24 over 25. And that would be 0.96. And then your tangent is opposite over adjacent. That's 7 over 24. And what you'll notice is your sine and cosine, any way you do it, they're always going to give you numbers that are less than 1, because the bottom number will always be the hypotenuse, and the hypotenuse is always the biggest of the 3 numbers. Tangent is the one that could give you a number that's greater than 1. It doesn't in this case, but it could. So that's sine, cosine, and tangent when you have a right triangle. And what we're going to get into is something called the unit circle, which you may have done in Algebra 2. But what you'll find is even when you're doing this different way of looking at trigonometry, it all comes back to this, what you do with right triangles. All right. Second thing I want to look at that's related to this, and you may or may not have done this before. These are called the reciprocal trig identities. So you can do like opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. You can also flip those. So there's other ways you could make ratios with the sides. And then those give us these three additional trig identities. And the first one is called cosecant. And there's also like a regular secant, but that actually comes next. But cosecant is the reciprocal of sine. So here we said on this triangle, sine, and I'll label these again really quick. This was our opposite side, our adjacent side down here at the bottom, and our hypotenuse right here. Our sine on this triangle, opposite over hypotenuse, was 7 over 25. So the cosecant is the reciprocal of that. So the cosecant is hypotenuse over opposite, or reciprocal of sine. So it would be 25 over 7. The next one here is called the secant, and that's the reciprocal of the cosine. So, and I forgot my thetas here. Let me squeeze in my thetas. Because whenever you do any of these, whether it's sine, cosine, tangent, secant, cosecant, it's always of an angle. You always have to have an angle you're basing this off of. So your secant would be adjacent, or hypotenuse over adjacent. Hypotenuse over adjacent, or it's the reciprocal of the cosine. So our cosine here was 24 over 25. So the secant would be 25 over 24. Just flip it. And finally, this is the easy one to remember. It's cotangent. So it makes sense. Cotangent goes with the tangent. And cotangent is your reciprocal of tangent. And so tangent is opposite over adjacent, the TOA. Cotangent is adjacent over opposite. So our tangent originally here was 7 over 24. Our cotangent would be 24 over 7. So the way I remember like which one's which is I remember that the sine and cosine always go with the one you think shouldn't go with it. So it would make sense for sine to go with secant, cosine to go to cosecant, but it doesn't work that way. The sine and cosine get switched. Sine goes with cosecant, cosine goes with regular secant. And then tangent's the one that just goes with the one that makes sense. So these are your 6 trigonometry identities or functions. And really sine and cosine and tangent are the ones you're going to use the most. But these other ones will come up sometimes, and it's good to be aware of them. And when you get into graphing these, it gets kind of fun when you deal with those other 3. But so I just wanted to make sure we reviewed right triangle trigonometry and made sure you were familiar with these 3, the cosecant, the secant, and the cotangent. So that's what we're going to start with, and then we'll get into a whole new realm of trigonometry later this week.